Is it 58?
It's what about 58, Matt?
There's nothing about 58.
No, except other than it is the numbers of shows that we've done. So welcome everyone to that's I'm cutting that out. We need a better intro than that. Matt.
There's got to be something about 58. It's probably a golden rectangular octagonal number or something. I have no idea.
That sounds right.
I need a bit of lead on those kind of bombshells.
All right. Intro us. Give us an intro, man.
Hi everyone. Welcome to episode 57. Index 57, that is. We got Aaron Roberts on the show today, visiting us from Austin. And like most of our guests, I feel like. And there's Graham. There's Graham Gansel in New Orleans. It's gone fuzzy already.
Again? All right. Yeah, so
I feel like you've gone fuzzy.
I'm gonna fix this. You just keep talking us in.
And I'm non-fuzzy, and I'm back in Nova Scotia. Several days. I had a week in the field last week. Literally in a field, or more of a clearing really, in Boston, doing GPR experiments. It's pretty fun.
That sounds awesome.
Yeah. Why? It was really good. It was my first exposure to like near surface geophysics.
Why were you acquiring the data?
We're working on a really interesting project to try and get better at detecting hazards and buried infrastructure on construction sites. So a bit of near surface geophysics, and basically to do the interpretation of those GPR images automatically. That's our goal.
But why were you collecting the data?
Well, this was actually a field experiment to help us calibrate that automatic interpretation.
Oh, so is this a potential offering for Agile Scientific?
Yeah,
data acquisition.
It's not a potential offering; it's literally an offering.
It's literally the first run.
As of last week, yeah. So I think people are thinking about, we've got a lot of data in geophysics, but we don't have a lot of labels. So one way to make sure you got labels is to actually bury the stuff that you're going to then detect, and then you know what everything is already. So it's kind of like a physical modeling experiment. And,
so did you go? So you went in a field with an excavator and buried bodies and manhole covers and stuff?
Exactly. Yeah. Yeah. Hardly any bodies in the end. It was very hard to get hold of that kind of thing. But
their acoustic impedance is relatively low.
But yeah, it was. And just getting to play with kind of real live action geophysics. And Evan's used GPR before, but I haven't, so it's kind of a new experience. It's kind of funny, right? Because it's not like seismic geophysics where you kind of go out and go, okay, well, I'm planting a receiver here, so I know exactly where this is. That's where my data is coming from. You're pushing like a shopping cart around, like a trolley. It's kind of jiggling around all over the place. and the GPS isn't good enough to tell you where those traces are coming from. So you've pretty much got to kind of measure everything in, and then say, okay, I'm going to try and get my data from these spots. But a bit of a survey challenge. It's not just like whip it out the back of the van and trundle it around over a field.
Okay, so you have some sort of low resolution geospatial information, and then how do you rectify the locations during processing, like doing surface statics or something?
We were lucky enough to have a flat field and enough room to kind of measure out what we wanted to do. But I don't know, operationally it's potentially a bit of overhead there with figuring out where everything is. Or you go for like a differential GPS, which you can plug into the instrument, and then you know the location of every line to within a few centimeters. Okay. We didn't have access to that this time around.
Can I make a suggestion? A marketing suggestion?
Please.
So on the way, and I'm an expert at this, by the way.
Hang on a sec.
There you go. The pen out. On the website, the offering is Agile Scientific will push things around in a shopping cart for you as long as they're GPRs. Yeah?
Well, that's pretty catchy. Yeah. I'll buy some.
I think so. Our guest today is Aaron Roberts. Aaron, welcome.
Thank you. How are you guys?
Good. Where are you?
I'm in my kitchen.
Okay. Where's your kitchen?
It is in my apartment, which is in Austin, Texas. I believe may have been mentioned before, but I'm not sure.
Yes. Well, welcome from Austin.
Thank you.
We're actually, Matt and I are headed over to the great state of Texas tomorrow.
Oh yeah, what area?
Houston.
Ooh.
Yep.
That'll be interesting.
It will be interesting. I'm very excited to see how recovery efforts are going and things like that. We're going to do a hackathon over there. It's going to be cool.
That's right. I remember you mentioned that now.
So Aaron is a friend of Undersampled Radio via his friend who's been on the show twice. His name's Ethan. So we're glad that we could get another real data scientist on board, because you are in fact a data scientist at LawnStarter, right?
That is true. That is indeed true.
What is LawnStarter?
Well, LawnStarter is basically Uber for lawn care. So the long and short of it is basically that we run a marketplace where if you are a provider of lawn care, we help you find people that need a lawn care provider. And I think that's about it.
If I needed help with the subsurface part of my lawn, could I hire Agile Scientific to put a shopping cart around in the lawn?
I'll see if we can get that on the roadmap.
Okay, thank you.
Hardly anyone thinks about what's going on under the lawn.
Yeah, well,
there could be unexploded ordnance under there.
That's very true.
Graves.
No, I was thinking more about agricultural constraints, maybe.
What do you mean?
I don't know. Well, I don't know. What, do they run subsurface piping or something? I don't know anything about lawn care.
Actually, I don't know anything about lawn care either.
Yeah. Okay. Well, that's good. So what do you do at LawnStarter if you don't know anything about lawns?
Yeah, basically I'm the data guy. I help push data around, and I help try to use it to make our essentially like matching algorithms a little bit smarter. You know, part of our premise is that we can make the business a little bit more lucrative for the providers of lawn care. And one of the ways that we do that is basically using location data to try to match them to customers. You know, the more time they spend in traffic, the less time they spend mowing lawns. And since it's also a seasonal business, they kind of have to greedily accept whatever job that they can, which means that just because, you know, it happens to be the case that they get a customer in South Austin and then a customer in North Austin early on in the season, they've now just set themselves up for not exactly an optimal scenario. So that's one of the areas in which we can help.
Yeah, right. That sort of optimization problem seems like it must be coming up quite a bit with various sort of location-based service offerings where people are connecting a market like that.
Yeah, exactly.
Is that big? Is there a lot of stuff going on in research-wise in that area? Do you keep up with that, or are you kind of just trying lots of things and seeing what works?
We just try lots of things and see how they work. One of the nice things that we have is an A/B testing system in our software that allows us to kind of experiment and, you know, actually see, are we making a difference in the ways that we intend to when we try out these new features. So yeah, not a ton of research in terms of like what are other people actually doing with this, but yeah, we have a couple of different ways of kind of dipping our toes into the water without fully committing to any given idea with that testing system.
Yeah, right. What does it look like? This sort of you know, cycle time from like, hey, I wonder if that could work, to actually like implementing it in an A/B test. Like, what is that? I mean, I guess it depends on what the idea is, but
yeah. So like, actually, for the stuff that I work on, actually pretty quickly, and I think that's mainly because I don't really have to rely, because of the system that we have built, I don't have to rely on very many other people to actually get a test out there. Because I actually do the ETL on our software's data, I can create the features that I need. You know, I'm self-service in that way, and then additionally, I maintain some of the endpoints on an API that we run that essentially give the results of my algorithms to our software. So I'm actually my own bottleneck in that sense.
A Klein bottle. That's cool. So so you could basically have an idea while you're brushing your teeth in the morning and have it rolled out by the afternoon, kind of thing.
Maybe not that fast, but yeah. I mean, we could have the idea in the backlog, and then but yeah, I mean, depending on how complicated it is, it could take a week or a couple days.
Yeah, right. Oh, that's cool. And are you guys rolled out now, like across the US, or do you go city by city like Uber does?
Yeah, it's city by city. Like we launch in a given market individually. When I started, we were in, I don't know, like 20 or so markets, and we're actually at this moment expanding into a much larger number of markets.
Awesome. Are you in Canada yet?
Ooh, I don't know about that. I don't know if there are any plans for that.
Snow shoveling? No snow shoveling services offered?
Well, actually, that idea has been thrown around. I mean, we have a really seasonal business, and a lot of these lawn care providers also in the winter do stuff like that as well. I think it's really a matter of building that into essentially like the provider and the customer software. The marketplace, there's no reason that it couldn't handle that kind of thing already.
Mm-hmm.
Yeah, like how about snow plowing for your neighborhood?
Yeah, exactly.
Who pays for that, but
I don't know who pays for that either. HOAs maybe.
Yeah, I guess. How about you, Matt? How's your lawn care? Are you in need of?
Yeah, we just have a sort of random relationship with someone that we probably saw cutting someone else's lawn, and got in touch with them, and they, I would say they drop by about the right amount. I'd say we probably turn them away, maybe one time in 3 that they come. Maybe they've come a bit too often, sort of thing, and we don't quite need it cutting again yet. But so it's a bit sort of haphazard, but they're very professional. They seem really good. But yeah, I have no idea like how they, like, this is Nova Scotia, so things are pretty word of mouth and pretty old school. They probably just have a haphazard way of growing their network. Yeah, and the snow thing, we have a really long driveway, so I care quite a bit about how our driveway gets plowed. I would definitely take advantage of that, because the guy that we have right now is a nightmare. I mean, he basically destroys the driveway. It's completely destroyed. Like by the spring, I've literally got probably half a ton of gravel sitting at the top of my driveway, where he's just like scraped it off the driveway and into the lawn, basically.
Well, you're touching on one of our value props for our customers, at least. You have a bad experience with our provider. We have a whole network of providers. We can get you another one fairly simply.
Right. So you have a ratings kind of thing when you get instant feedback.
Yeah.
Yeah. I mean, that's the marvelous thing about, say what you like about Uber, but they've nailed the sort of customer experience. Like, it's just such a easy, great thing. And the ratings are great. I just think such a fantastic way of essentially getting the behaviors you want out of both sides of the market.
Yeah, exactly. Or at least incentivizing the behaviors that you want.
Yeah. I guess it doesn't work all the time, but.
Right, because if you have, it's related to if you launch a new market, you have a limited amount of supply. Well, they could be rated poorly every single time, and they're still going to get every job because we have a limited amount of supply, and that's related to just the dynamics of how do you spin up a new market.
Right.
So the incentives are there. Your luxury as far as can you actually get a good provider or not? Well, that really does depend on the volume of the supply.
Yeah.
It sounds like you're doing a lot of different types of things at LawnStarter.
I am.
You're A/B testing, you're designing algorithms, you're building web stuff. Is there what don't you do? Maybe is a better question.
Yeah, I don't know. I don't prioritize the feature list that our other engineers build. How about that? But there are several of us that are doing probably stretch a little bit too thin in terms of the number of things we're responsible for. But that's a startup.
What we've been talking a lot recently here on the show about data science as a profession. What, in your view, are the top things a real actual data scientist working for a company? What are the top things that they need to know how to do?
Well, I would say first and foremost, I need to know a little bit of math. You can go, learn Python all you want, but if you can't make sense of the numbers, then you're not going to be very useful. But I think one of the main things is just being, flexible enough to know how to pull data from anywhere and start making use of it. I mean, that's kind of the essence of the job title is we're, producing data everywhere and we're trying to figure out how to use it. So if you can't go get the data and, make it manageable, then I don't know what you're going to do.
Yeah, I mean that's that's something we deal with as earth scientists as well, right? It's just you can't always get the thing you want. You might have to use some kind of proxy.
Yeah.
Even the proxy might have other issues or not be very accessible.
The buried corpses and whatnot that we were mentioning before.
But yeah, you use what you can get and try and maybe find a way to get the data you really want, like starting today. And that is part of the fun of it, isn't it? What is your background? Did you start out as a mathematician or a computer scientist or? Sort
of. I did math and physics in undergrad, and then I went to grad school for physics, but I left after, I guess it was 3.5 years. I got my master's and decided to move on. But yeah, so formerly, in the physical sciences, but I'm far enough away from it that's all gone. That's all in the past.
Right. That's interesting. That I definitely detect a trend. I don't know if it's just our guests and the people I know, but there's definitely physics there's a big group of people in our space who've come from a physics background.
Yeah, it does seem to be that way. And I think actually, when you asked before, what are the things that data scientist needs to be able to do? Actually being able to do research, I think, is a critical part of it. I mean, with the variety of problems that I'm exposed to at my job, for example, I don't know all the algorithms. I don't know all of the types of ETL frameworks. Like, I have to be able to go kind of on the fly, be able to figure out what is the right approach for the particular problem that we're on. And then additionally, learn the tools and learn the solutions. So if you can't actually do that kind of research, then you need a very structured environment to actually even contribute. And I think that's probably where like the preference towards advanced degree, especially like physical sciences students, comes from.
Yeah, right.
How much research type stuff actually goes on in business? Like how much testing happens before toolkits are decided on, and et cetera?
I don't know. I'm not actually sure that I can generalize on that. And it probably depends on the company as well. We push things out with a level of rigor that maybe other companies might not want to push things out on because they have the luxury to wait. So I would say the answer to that is highly, highly variable.
Well, it's cool. There's a lot of stuff out there to learn, and that's the best part about working in this wide framework, right? You have like a lot of different problems, and you get to learn a whole bunch of new stuff every time you do a new project.
Yeah, it's also a bit of a problem because everything sounds so cool. You got to figure out what problems to focus on. Like, should I play with this tool today or this tool tomorrow? Like, no, we got actual problems to solve. So let's make sure that we keep that in mind as well.
That's true. I've been talking to a friend about doing machine learning based on graph instead of based on relational databases. And Matt knows him. His name's Steve Purvis. He assembled this, and he's ridiculously good. He's like, I don't understand how he works so quickly, but he's assembled this awesome list of like graph ML resources, right? And it's like 40 pages long. I'm like, how do I?
The list is 40 pages?
The list, yeah. It's ridiculous. It's awesome. So I feel like I need to
is it sorted at least?
So my hackathon project is going to be just purely reading what Steve's gone through.
Produce the Cliff Notes.
Yeah, I guess so. Here's a good question. Here's a good question that I wanted to ask that I didn't remember to write down the show notes.
I didn't get to prepare.
Yeah, so you'd have to answer this right now, but you have to answer it by the end of the show.
Okay.
Yeah. So the hackathon is a geoscience-oriented gig, and that's just because we have a lot of geoscience friends. And the theme is machine learning. However, we're also going to be having this hackathon in a town that was recently impacted by a hurricane. And so we're also trying to incorporate disaster relief stuff in. So chew on that for the length of this episode and come back to us with a cool project at the end that I can steal and use.
That's a tough order.
That's all.
That's all. Machine learning, disaster relief, whatever.
What kind of data is already out there about this kind of stuff? I haven't done any exploration. Like, can you get any data and put it on a map?
Yes, that's certainly a thing. There's all sorts of weather-related data. There's information available about recovery efforts. All the FEMA data is public. Most of the FEMA data is publicly available. It's a lot of cool stuff relating to resources like human resources and materials resources for the recovery effort. So I don't know. I haven't actually decided on a project yet. I have like about a bunch of ideas, and I don't know. Matt, are you going to work on a project? Do you know what you're going to do?
I usually start with some sort of dream of maybe hacking on something and then not really getting very far with it. Yeah, I mean, like all of us, I've got a list in my head of about 30 things I'd love to try at some point.
Yeah.
And some of them have been on that list for probably 3 years.
Yeah.
It's pretty sad. But yeah, there's been some good chat on the Software Underground about some projects last couple of hours anyway. This morning there were some ideas. So it's been interesting hearing from the people who have been at a food bank, say, trying to help distribute food, and just saying stuff like, what did Rafael Pinto said yesterday? He spent the whole time just reading or trying to find, interpret, and translate best before dates on food items. And that seemed to be a massive sort of, it's not the sort of thing you think about, right? But yeah, it's actually a real pain in the neck when you're trying to get a lot of food out to a lot of people and you don't really know where the food came from. So, we will have some people there who've been involved in projects like that, and a couple of people who know about a large number of projects with FEMA and other things. So I think we'll be able to find projects that line up with people's interests and the sort of data we've got access to. Yeah, so I wanted to ask Aaron, is the company distributed? Is everyone based in Austin, or are you from there, or how did you wind up in Austin?
I wound up at Austin originally because of grad school. I went to UT here.
Right, nice.
The company has a couple of distributed team members, but yeah, Austin is the primary office location.
All right. It seems like there's a really sound, solid tech scene there.
Yes, definitely, and growing. I don't know if you know how much Austin is growing, but no, it's getting crowded. So I was at UT for 3.5 years. I moved around for a couple of years, moved back to Austin, and in the 2 years I was gone, it's just not even the same place anymore. The skyline is different. I mean, there are just condos that weren't there before, and yeah, there are a lot of cranes.
Right. Yeah. Well, that's great for Austin, I guess. It's always a bit of a, I don't know, catch-22, isn't it? Like you want to see places do well and be successful, but you also would like to have an affordable place to live and park.
There's that, and I don't know if you've heard the phrase "keep Austin weird," but yeah, as more and more people come here, I think that kind of is less and less a reality. Yeah,
right. Well, it'll be interesting to see what happens. Maybe you'll end up with like a weird ghetto.
Yeah.
I don't know if that would be good or not.
Yeah,
but that's cool. I think it's really awesome when you get these places that just have this kind of real sense of common purpose and people are sharing ideas, or that you've got that kind of offline network / community of folks, because I'm sure there's lots of events going on and things that are oriented towards the tech scene.
Yeah, definitely. Kind of and even like just downtown Austin is kind of small, so like just physically you have proximity to a lot of the same types of people. So I think that's a good thing as well.
Yeah, right. Well, that's cool. So I'm looking at did you write these things, or is this I feel like cryptocurrency and baseball, Graham has to have written those.
Yeah, those are his notes.
Well, okay, so here's the deal. I was in Austin the other day. We just went out, and Aaron and I, first time we met, we were just chatting, and we went all over these topics, and I don't know, I just think they'd be cool things to talk about.
Yeah, we did touch on a lot of topics.
I just wanted to basically record the conversation we already had.
Yeah, right. Yeah. So the baseball model, are you another one of these fantasy baseballists?
No, that's kind of a past life. It's actually that project alone might be the reason that I left grad school for physics. So I guess the story was, for me, as an undergrad, I never wrote a single line of code. When I went to grad school, I wanted to do theory originally. Then come my first summer, I needed funding, so I joined an experimental group, and I had to analyze some data in MATLAB, and that was about the end of it. I just really enjoyed working in MATLAB, and I don't really know where I got the idea for the baseball project, but I had an idea about some stuff that I could do with baseball statistics and essentially, try to predict who's going to win a game, that kind of stuff. Yeah, there was a good period of time where I was pretty interested in gambling on sports, but like I said, that's maybe in the past.
Yeah, that's cool though. I feel like a lot of I definitely identify with that sort of discovery of computers and that realization that suddenly you look at every single thing, like problem anyway, differently.
Yes, exactly. Like the particular problem that I was trying to work on was essentially measuring the size of a laser, essentially, like the diameter of the profile, and it was very tedious. And so I spent a lot of time like actually building a program that would make it much faster. And that's when I kind of like realized, the power of being able to write code and, just automate things.
Yeah, right. And the thing that I think I've only sort of more recently started to think about is the added bonus sort of doing it that way is that it's explicitly documented and intelligible to someone, like in a way that a kind of hacky manual, whatever, heterogeneous workflow with Excel and the back of an envelope is just never going to be reproducible. Code actually is like, no, this is exactly what I'm doing. Like this. Well,
I will say it is a challenge to produce, reusable and maintainable code.
Yeah, sure.
There isn't, an art to doing that. But yeah, it's not like it does all exist in one place. Like technically, if you can look at a script, you can kind of figure out what it's doing. So.
Right. Yeah, and it's completely sort of explicit, which I think, when I look back at, there's all sorts of things I did early in my career and at grad school that there's no way I documented them well enough to know how I actually did them.
Yeah, I think that's actually probably the reason that the whole baseball project didn't make it a little farther than I did, because I had several manifestations of the project, but the first one was in MATLAB, and then the second one was in like VBA because I was trying to be an actuary at the time, and that's a language they wanted to see. And every one of them, like the idea was very simple, but I re-implemented everything from scratch each time I did it because I wasn't essentially very good at software development. I didn't really know. So it was a little bit of a limiting factor, actually. Yeah, I don't know. But it's like I said, it's probably good that those things got left in the past.
But they were pivotal nonetheless.
Yeah,
it's always interesting to go back and read your old code because it's so much junkier than your stuff.
It's depressing. It's depressing to read your old code.
No, I love it. I see it as a sign of personal development.
That's true. That's true. You look in this directory up here, it's good. You look in the directory below that, not so good. So progress.
That's right. Hey, speaking of which, why is it so hard to install CUDA and the deep neural network framework for CUDA?
I don't know the answer to that question.
It's driving me nuts.
I've had installation issues with packages in the past, but that particular one, I don't know. At LawnStarter, our data is not big enough to really warrant throwing that kind of like toolage at it, I think.
I'm updating one of my Amazon images right now because to use TensorFlow with the specific GPUs, you need the new version of cuDNN, and it's like it's the worst. I don't know. It's one of the worst installs I've ever done. And I'm going back through this. I was thinking about this today. I don't think I've ever actually successfully installed CUDA on a computer with a monitor, with like a graphics display. I don't think I've ever gotten it to work.
That's funny.
Oh, wow. That's a shame.
It is a shame. So yeah, there you go.
Yeah.
Well,
I guess I don't have it on my laptop, but I have it on my Mac. It seemed okay, but
it's not so bad on a headless machine. But I don't know. I just remember hours and weeks going by of me trying to get this thing working in the office, and I was just like, screw it, I'll put it on Amazon.
Yeah, it is a highly prevalent package though, so I don't know. Something to the effect of user error is coming to mind here.
So the reason I'm doing this is because I've been playing with TensorBoard recently. You guys mess with TensorBoard?
I've not.
It's cool. It's a way to visualize your various operations that you write in TensorFlow. And I was headed in the direction. Now I've finished, but I started the project because I wanted to figure out how to in a pretty way visualize latent space information in neural networks. And TensorBoard makes it very nice. If you haven't used it, totally recommend it. But in playing with this stuff, it's made me really realize how graph is applicable to operations, not just data. And if you think about a graph database as being the antithesis of a relational database, then I find that you can think about any sort of operations, like computational operations, as a graph in which the nodes are operations and the links are information flow. So it makes me think of abstract algebra, like this, you're sort of like building this structure in operations space. And I'm sure you could find like isomorphic, there's some like set of isomorphic operational graphs. I actually don't know where I'm going with this idea. I've just been thinking about this a little bit over the past week. What do you think, Matt? How's your TensorBoard experience?
Yeah, I haven't thought about it as deeply as you have, I don't think. I mean, for us, it's just been essentially a very easy way to see what's happening with your, GANs or ConvNets or whatever. Because, they produce a lot of output potentially. So it can be a bit hard to make sense of everything.
Do you, in an alternative setting, do you visualize or represent the internal state of your networks?
No.
Just with TensorBoard?
Yeah.
Yeah. Why is that? Because it's so easy, I guess.
Yeah. Now, did I? Yeah, I mean, yeah, basically because it's so easy. But I haven't paid a lot of attention to the graph representation of the network.
Yeah.
I mean, I'm really interested in graphs as a way to express relationships between data elements, but I haven't thought about it as an abstraction of, I don't know, algebra or whatever.
It doesn't have to be algebra, but like any sort of operation.
A logical system or whatever. Is it? Yeah. I don't know.
Okay. So in going through this thing, I realized that I haven't spent enough time sort of analyzing internal state of my systems, and it makes you very quickly realize what is useless. Like I built a network the other day, and it's like half of the layers, half the stuff I put in there wasn't learning anything, wasn't doing anything. Right. So you can visualize that information. Boop, you can just drop it, and then you have a much faster performing thing.
Mm-hmm. Right. Some things just never get activated, essentially.
Yeah, or if they get activated, they don't change over time, over training epochs or whatever. So
that's pretty interesting.
Yeah. So whether you're using TensorBoard or not, I totally recommend now, as of the past week, visualizing in some quantitative way the internal state of the network. Is quickly you'll see that you're wasting your time.
So can you kind of use that as a tool to understand, like, the architectures that you're using when you're developing a neural net? Like, I mean, can you use that to inform like your development choices, I guess?
Indeed. So I think that probably the reason that TensorBoard was created, I'm just guessing, is to debug. I just keep saying neural networks, but it could be anything. Any sort of large operational workflow. And yeah, it's pretty amazing what you see. I'm going to try to pull one up right here while we're talking.
I'm going to make a note to myself to actually check this out. I saw that you mentioned it before, but I just haven't had any time to do it.
Yeah, it's pretty cool. If you know TensorFlow, it's real easy to get into it. Look at this. Is it going to work? Yeah, it's going to work live. All right, folks. If you're listening, if you're tuned in live on YouTube, you're in for a treat. If you're not watching this, if you're listening to this as a podcast, you're not in for a treat. But anyway, I'm going to share it anyway. Here we go.
That'd be a good hackathon project, adding sound to TensorBoard.
Yeah, there you go. So here's a TensorBoard. Can everyone see this? Yeah. So this is is just a fairly shallow convolutional neural network, and so you've got these. Here's a convolutional node. It's like a super node, and inside the super node, you've got operations, which are, your standard thing, and you can see your outputs here. So on this subgraph, you see your loss function, and again, if you're not watching this, what you get is sort of this interface between supernodes, which represent like logical operations, and their flow, the information flowing between them. As you can see over here, you have these real thick edges or links. Those represent tensors that are larger in dimension than the smaller ones. And then you go through a validation operation here. So it's a pretty cool debugging tool to look at the structure of a workflow, but it's also good to analyze the loss and the state here. Oh, there's some random noise. That's not a good state. But anyway, I'm going to stop pointing at things that the podcast listeners can't see now, but check it out. It's lovely.
Yeah, it reminds me a bit of, well, those, well, they don't remind me, but it makes me think a bit of seismic processing and how awesome it would be to have that kind of dynamic view into your seismic processing flow.
Ah, you've never tried SizeUp then?
Who?
SizeUp?
SizeUp? I've never even heard of SizeUp.
Well, get on it, man. It's okay. So there's a guy named Art Gray in Houston with a company called Generation Services. He and I'm totally going to get this wrong, but I think it was his partner and Art who built the original SizeUp. And now it's owned, they sold it, it's owned by someone else.
And what does it, which process, can it plug into any processing system?
No, it is.
Oh, it is a processing system.
Software. Cymax now owns it. God, why these names are terrible.
Cymax
and SizeUp at, yeah, cymextech.com. But they do have a flow, sort of like a workflow diagram. So basically what we're talking about here, Aaron, is you receive raw noise records, which is just energy propagated through the earth. And you want to somehow turn it into geology-ish stuff. And to do that, you have to go through a lot of wave field processing steps. And this software does that graphically. Like, it's actually kind of VBA-ish. But you like plug modules together using, or that's actually, you know what it's like? It's like LabVIEW. You like plug modules together with links. Yeah. It's pretty cool.
I kind of like that. I also like the block programming sort of paradigm, like Scratch and.
Yeah, what's that Google made with code language?
I don't know, but they had a development environment for Android. I think it still exists. I think it's also like Scratch, an MIT product now. App Inventor was a way to build Android apps in this visual programming environment. And it always struck me that that would be a really great environment to build seismic processing.
Yeah, could you take that tensor board sort of view and use that to actually construct your networks? Is that a possibility?
Right.
It doesn't exist that way now, but it's a really good idea.
Yeah.
You can't edit them at all in that view, eh?
No.
No.
No, unfortunately not. There's a. I'm sure you have kids, Matt. I'm sure you've played with this. Google Made with Code. Yes.
I don't think so. No, doesn't sound familiar.
It's the same thing. Block programming.
Okay. Cool.
IDE where they give you little challenges and you play with it. It's horribly addicting. Like I think when I found out about it, I wasted half a day playing with it. I'm just on the web right now trying to blockly.
What I really remember liking, I played with a thing called AVS way back, which sounds a bit like it might be a bit like LabVIEW, and it was basically a way of building a flow, and data went in, and then you could like have visualizations of different. Basically just plug in a visualization block wherever you like and configure everything within its piece. And, it's basically just programming. But it seemed like a really nice way of sort of exposing the complete API because it was so visual and you were choosing everything from a box of stuff, like from a palette. You could see all the options open to you at every spot, right? It's like, what can I do with this data? Oh, well, here's, because it strikes me that API exploration and discovery is a real, I don't want to call it a roadblock, but I mean, there's a speed bump there for beginners, right?
There's a speed bump there for experts who are switching toolkits.
Yeah, sure, experts too. I mean, I practically every day discover another NumPy function I didn't know about.
Yep.
That I've been doing in some wacky way or slow way before.
And I know that feeling.
Yeah. I mean, it almost seems to go on forever.
It's almost worth, like, even when you know exactly how you might accomplish something, still search for it on Stack Overflow because chances are there's a NumPy function.
Yeah. It's the sort of Aladdin's cave of APIs.
Hey, did you see the show note here about Tortuga Ag Tech?
Yeah,
I saw that.
What is that?
I don't really know actually, but there's a link in there for anybody who's interested. I think that they're trying to use optical measurements, at least optical, and maybe other wavelengths to analyze growth of crops and optimize them.
Was it about the crop growth, or was it about the actual act of harvesting?
I don't know. You tell me. I only know what is on the splash page.
I just remember seeing a fairly nimble-looking robot arm, and
yes.
So that suggested to me that it was probably for harvesting.
Oh, I thought that was just a camera.
Oh, maybe it was. I don't know.
And then you've put something in here about packing, which made me think of looking at the box and going, "We need a zucchini that's exactly this shape."
Or maybe they can take the zucchini and fit it in whatever package works best.
Right.
So the question here is, has this data analytics craze gone too far? Or is this a good idea?
Which part of it?
Just order something small from Amazon and you find out that they don't have a packing algorithm.
Yeah, you're right. I think their algorithm is, if it's a certain size, give you this box, otherwise give you a bigger box.
Right.
I mean,
fill it with all this weird air packaging.
Yeah, I had so much packaging from things that were just in way too big of boxes when I moved apartments and got some new stuff recently.
Yeah, right.
I mean, I guess the question is, does the IoT, is it going to live up to its promise? I mean, when we have nimble robot arms with cameras and clippers on the ends, I mean, is it?
I don't know. I was thinking specifically about the Tortuga Ag Tech, was that what they were called? Yeah. I was thinking specifically in that region, it definitely is worthwhile, I think, to automate the harvesting of plants. I told you that I was growing hydroponically in my apartment, and it would take me like half an hour to pick the lettuce that I need for, just one harvest and a salad for a couple of days. Like it's a highly manual process. And like, granted, I was like sort of fighting the geometry that I was in a little bit, but still going in there and manually doing that, if you wanted to be, a small operation hydroponic grower, like there's a lot of manual labor involved with that, let alone like actually, optimizing your plant growth,
So the answer is yes.
I believe, yeah. I mean, maybe or maybe not for the like actual optimization of the growth, but for actually helping you accomplish some of the physical tasks, for sure. There's definitely room for help there.
Well, why not growth optimization?
My first thought there is because it's almost too easy to grow hydroponically. So I'd never grown a plant in my entire life. I got this system. We set up a water pump. It, makes sure that we water the plants at some frequency. I turn on a light, and I had huge lettuce plants. And I've never done this before. So like, it was so easy. It was so easy. And so like,
it turns out that nature's already done the optimization.
Yeah. I mean, I guess optimization makes sense when you're at a huge scale where it's like, we improve our efficiency by 1%, and that's a lot of money. But sorry, and I'm just thinking about my own use case, like, where I'm just a small guy and I have a few plants that I'm managing. There's no reason that I would optimize that. But what I would want help with is the actual work of going and, harvesting these plants, because it is a lot of work, actually.
Sure. So John Deere sells a tractor for $3 million that has a GPS system in it that drives your little harvesting wizard around the field and picks your lettuce. I'm
100% positive that this exists like in commercial farming, but
it does.
But what I'm talking about is like the like I'm one guy and I have a small indoor space that I'm growing in, because this whole
indoor a little robot to go in there with scissors.
You need some help.
Cool. Matt, there you go. You already bounce around in fields with shopping carts. Just slap some scissors on that puppy and call it a picking tool.
The most kind of, and I assume this was a sort of invention, or at least a realization, innovative picking strategy I know about is the one that they use on cranberries, where you know how to pick cranberries?
No, I just can't say I do.
Yeah, well, they're hollow, right? So they float. So you just flood your cranberry field, and they'll come off, and now they're on top of the water, and then you just scrape them in, skim them off. So it's easy. It's just a really cool quirk of nature that there's a really easy way to pick a whole field of cranberries in about 15 minutes with no
flood
view.
The whole thing.
Yeah.
So I guess only the ones that are ripe come off because the stem is too strong for the ones that aren't ready, or something, or like.
I'm thinking, I don't know how many floods it takes to pick them, or if they're all ready at once, or quite how that works. But yeah, I think it sort of just all looks after itself. Maybe they have if they're slightly underripe, they use them for a different purpose, like juice or whatever.
Don't they shake olive trees? Don't they have a thing?
That's right. Yeah, yeah, for sure. Olives or almonds or something where they just vibrate the whole tree. Yeah.
This is why we've been called a vaguely science-focused podcast by Imperial College, because we talk about stuff we have no idea what we're talking about.
It's the classic pub conversation of half-remembered pseudo facts.
Yeah, where you transition from. I think it might work like this. Yeah, it definitely works like this.
Turns out,
definitely,
it's actually blueberries, and someone tried it once and it didn't work at all. But yeah.
But that's how it works now.
Worse because we actually have Google here, and we just refuse to use it. We just keep insinuating things.
I feel like you could pick anything with the cranberry strategy if you can just find a dense enough liquid. Like you could pick apples that way with mercury.
But you have to make sure that the fruit has a difference in density that is favorable compared to the plant itself, right? Compared
to the plant, right? And all the other things on the plant. That's a good point. Otherwise, you just pick everything.
Just anchor the plant. Yeah.
All the leaves and all the tree branches and birds and
Yeah, but you know, fruit when it's ripe, you know, it falls off the tree, right? So that's why I was thinking, like, maybe when it's ready, like, you don't actually need that strong of a force or anything like that.
Right, right. It's self-selecting.
Aaron, what are you reading these days?
I recently started reading a book called Defending Beef. And
Oh,
yes, this is something that we haven't talked about yet, actually.
Barbecue.
well, let's do it.
Well, I get my hair cut about once every 3 months, and a few months ago, I was getting my hair cut, and the person cutting my hair was telling me about some, you know, health documentary. It was related to the food system and stuff like that. And she was like, "Yeah, you should totally watch it." And I came home, and it just happened to be the case that my girlfriend was watching it.
Oh,
So,
cool.
we watched it, and granted, this documentary was pretty hokey, but it was about basically promoting a vegan diet. And but we started watching, or at least I started watching more documentaries that are in kind of they have a similar thrust, I suppose. And some commonalities emerged. Anyway, me and my girlfriend decided to try to be vegans, which I'm embarrassed to say it out loud, but we did. But you know how you end up in those echo chambers that are produced by recommendation systems? I found myself believing that beef was like the worst thing in the entire world. And I know that there are some problems with our food systems, and particularly the way that we produce beef on a large scale. But I just got to the point where I needed a different opinion other than, you know, vegan is the best thing you can do for, you know, the environment and your health and all this kind of stuff. And so, yeah, it's called Defending Beef, and it's basically describing, it's not defending at all sort of the industrialized, you know, beef production system that we have, but it is talking a lot about the benefits that essentially the interaction between cattle and grassland has on the ecology and stuff like that. So it was interesting, and it is interesting, I should say, and it's good to get a different opinion other than the ones Netflix keeps trying to force down my throat. So
did it work? Are you eating steaks again?
Well, the vegan diet, it's kind of like at an 80-20 state. So, you know, on the weekend we eat meat and other things, and try not to as much during the week.
Well, it's probably for the best. Try to you know, mitigate consumption. That's cool.
Yeah, I'm just hungry a lot during the week.
Is the author Nicolette Hahn Niemann?
I can Google that right now and let you know.
Okay, I just want to make sure I have the right link in the show notes. While you do that, Matt, what are you
Yeah,
reading?
that looks right.
Okay.
I'm just between books, I guess. I just finished the Computer Science Distilled book that I mentioned before.
Yep.
And I'm just about to start. I think I might, well, I don't know. I'll probably take some papers to read on the plane tomorrow, but I might bring it for the way home. I picked up a book called On the Abolition of All Political Parties by Simone Weil, or Weil. Anyway, not sure how she pronounces it, but W-E-I-L. Which is quite a short little book. I don't normally read political books, so we'll see how far I get with it. But I guess, you know, I'm curious about the for and against of political parties. I feel like maybe they cause more problems than they're worth, but maybe I don't know.
So it's not
of
a
the story.
discussion of like our implementation of the party system, but just the idea of a party system, or?
I actually don't know anything about it other than the title. So I don't know if it's for or against. As I was looking for it now to make sure I got her name right, it looks like it might be an older book. So I don't know if it's mostly a sort of philosophical treatment, a, you know, quote unquote timeless philosophical treatment, or if it's specifically about today's parties in some particular country. Oh, it's from 1943. In fact, I'm reading now. So it's definitely not about today's political parties, but maybe it has some interesting insights about.
Yeah, maybe it will be prophetic.
Yeah, I was just thinking, let's hope it isn't prophetic. Yeah, and I think she's French. So she's probably had some pretty direct and awful experience from the time.
Well,
What
good
are you
luck with
reading,
it.
Graham? Yeah, thanks. Yeah.
I'm reading a book called Super Sense by Bruce Hood, which is about the why supernatural beliefs are a thing and how human beings come up with these ideas. It's okay. It's not my favorite. You know, did you read the book Spook by Mary Roach?
No.
Okay. So that was along the same vein. But it was Mary Roach's book was funny and had what I would call more factual information in it. This book is good. It's interesting, but it's a little lacking in detail. So yeah.
So to be clear, you're talking about aliens?
No, I'm talking about ghosts.
Okay.
And luck and variety of other things, but I guess aliens too. Yeah.
Yeah, just things that go bump in the night.
Yep. Matt. Hey Matt. Oh, actually no. Let's we have another thing to do today. Hey Aaron.
Yes.
All right. What's your hackathon project?
You know, where my mind went initially was kind of like, and this is why I asked what data can you put on a map. I wasn't talking about weather. I was kind of talking about like where the resources exist. So I was kind of trying to think of like mapping resources to disasters and like population densities. That's as specific as I got in the about 5 seconds I got to think about it.
I like that idea. I mean, you could migrate. You could like map in migration of resources or something like bottlenecks in resource transport. That'd be cool.
TensorBoard. Sounds like TensorBoard.
And with that, we're off. But I wanted to mention before we sign off, we will be with you next week, live and direct from, and actually, I'm really talking about this weekend from the hackathon. So
Okay, cool.
Get prepared to see us in hacking action.
Do we know
Houston.
what day we might try and do that yet?
But I don't know. You're the busy one, man.
Yeah.
You tell me.
Maybe Saturday or Sunday. Well, we'll try and plan something and get a link up on the Twitter feed.
Okay.
And Software Underground maybe.
Like 5 minutes before.
Yeah.
Which is usually how we do it. Okay. See you next time on Undersampled Radio.
All right. Cheers. Nice to meet you, Aaron.